In a previous webinar, I showed how to use the OpendTect OD-bind Python module to calculate seismic attributes. Today, I want to show yet another way Python code can be used to calculate attributes with an OpendTect, the WMPlugin's external attribute plugin. My setup for this demo is the latest OpendTect free release 7.04, the OpendTect Miniconda 3 Python environment, WMPlugin's version 7.0.4b, and the F3 Demo 2023 survey. The same workflow will also work in OpendTect Pro and the OpendTect ML Python environments. During the demo, I will show how to code a Python external attribute script to calculate simple complex trace attributes, how this external attribute can be used just like a native OpendTect attribute. Namely, it can be displayed on inlines, crosslines, z-slices, and random lines. It can be used as input to other OpendTect attributes. It can be realized to a disk volume using the Processing Create Seismic Output menu. Before the demo, I'd like to present some background for those who are not familiar with WMPlugins. WMPlugins is a suite of free open source OpendTect plugins that I develop. The source code is freely available and released under the GPL3 open source license. Binary packages are available for Linux and Windows through the OpendTect Installation Manager. Shown here are links to the source code and documentation repositories on GitHub. The external attribute plugin is a combination of an OpendTect attribute engine plugin and a Python module. Together, these provide a framework for an external Python script to communicate with OpendTect, to display a user interface, and exchange seismic trace data. Installation of WM plugins will add a bin Python WMPy folder to the OpendTect software installation. In that folder are some Python modules that support the external attribute plugin, as well as a selection of external attribute scripts. In this demo, I hope to show that it is relatively easy to write and use your own Python attribute scripts. We'll start by writing the code to compute some simple complex trace attributes. First, the code imports NumPy and the Hilbert function from the SciPy signal module. The Hilbert function will be used to compute the Hilbert transform of the input seismic data. Next, the exattrib Python module is imported. I add the bin Python folder of the OpendTect installation to the Python path, so the import can find the module. Next, the code defines the xa.params Python dictionary that describes the attribute's UI. The inputs item is a list of the input names. Only a single input is shown in this case, but multi-attribute input is possible. The output item is a list of the output data names. This attribute only has one input parameter, the standard deviation of the input data. This will be used to scale the data before calculating the Hilbert transform. Finally, there is a flag to control if parallel processing will be used by the OpendTect attribute engine. This attribute is so simple that parallel processing doesn't improve performance. There are a variety of items that can be specified in the xa.params dictionary to construct fairly complex UIs. I suggest you look at the WMPlugins documentation and the scripts in the WMPy folder to learn more. Next, the code defines a function to do the attribute calculation called doCompute. This function will be called once per run. The head of this function is a good place to retrieve input parameters from the xa.params dictionary. In this case, the scaling factor is retrieved. The actual attribute calculation occurs in the while loop. The loop is transversed once for each and every attribute calculation location. At each input location, the external attribute plugin writes the input data to the input pipe of the script. The xa.doInput function reads the trace data from the pipe and puts it into the xa input dictionary. The code scales the input data, computes the Hilbert transform, and then uses NumPy to calculate the attributes. These are saved into the xa.output dictionary under the appropriate keys. The xa.doOutput function then writes the data to the script's output pipe, where it is read by the external attribute plugin and transferred to OpendTect. When there are no more data locations to process, The external attribute plugin will break the pipe, which stops the loop and the script. The final two lines are a bit of boilerplate, so the XA module knows what function to call for the attribute calculation while the final line runs the code. So that's it. We can save the script somewhere where it can be found from OpendTect. To use it, just open a new attribute set, select the WMPlugin's external attribute, click through the warning and use the script file selector to find the script. If there are no syntax errors, the attributes UI will be built from the script's params dictionary. From this point, it's just like working with a native OpendTect attribute. We define particular attributes in the set for the scaled input and instantaneous amplitude, and then save the set. These can then be displayed in the tree on inlines, cross lines, Z slices, and random lines. Note that each time we display the attribute, the Python script is rerun. Now, the external attribute can also be used as input to other native OpendTect attributes or even other external attributes. Let's use the native OpendTect instantaneous attribute to calculate instantaneous amplitude using the scaled data generated by the external attribute. Also, we'll use the OpendTect mathematics attribute to compute the absolute difference between the native and external instantaneous amplitudes. We can display these on an inline and see that the calculations return essentially the same results except for some minor edge effects. Finally, we can use the Processing Compute Seismic Data menu to generate a new output seismic volume on disk with the data generated by the external attribute script. Again, the workflow within OpendTect is identical to using a native OpendTect attribute. There is some overhead in shuffling of data between OpendTect and the external attribute script, so expect external attributes to run a bit slower than native attributes. Generating the multi-attribute volume for the entire F3 demo survey using the external attribute takes just under 3 minutes versus just under 2.5 minutes for the native attribute. So there you have it, another way Python and OpendTect can be used together. While attribute calculation using the ODBind module is significantly faster, the external attribute plugin offers a relatively seamless user experience within the OpendTect user interface. It's your choice. Thanks for watching.